Hello viewers, welcome to Unacademy YouTube channel. Welcome to Unacademy Plus course. Myself R.Vetrivel, Unacademy Plus Physics Educator. Welcome all the viewers for today's session. Today we are going to discuss electric current and electric energy. Welcome all the viewers. So let's learn from the India's topmost teaching and coaching platform, Unacademy. It is the best plan for all the students, those who are preparing for competitive examination. So you can use my code VETRILIVE to subscribe Unacademy Plus course. So today we are going to discuss electric current and electric energy. Let us start today's session. We all know Joule's heating. So remember, Joule's heating is nothing but Joule's law. Whenever we apply the potential difference to the resistance, the amount of work done to move the charge for the entire circuit, the work done to move the charge is Q into V. As we all know, potential difference is work done to bring the charge from infinity to that point, right? Here, external resistance in the conductor, I apply that external voltage, right? Give connection to battery. So the work done to move the charge through this entire circuit from higher potential to lower potential, that work done equal to Q into V. We know that Q is IT into V. So Q equal to I into T. So V equal from Ohm's law, V equal to I into R. So you will get I square RT. Right. So this I equal to again V by R. Then I square place substitute V by R. You will get V square by R square. This R will cancel. We will get V square by R into T. This work done only here produced in the form of thermal energy. This work done whenever we apply the external source, right? This work done only appears as thermal energy that is produced in the resistance in the form of the heat. So the work done to move the charge whenever we apply the external electric field, right, voltage, when you apply positive negative, the work done to move the charge over this entire circuit, Q into V, right? So Q we can write IT, we know that formula now, W equal to I square RT, right? This work done only appears in the form of thermal energy across the resistor. So this we can write as a heat now. So V square by R into T. So this is called actually Joule's heating. Right? Joule's heating, as we all know, according to Joule's law, the work done is directly proportional to heat produced. Work done is equal to JH, where J is called Joule's constant or mechanical equivalent of heat. From this, heat equal work done by J. That work done only, this formula all we can use, right? We can write this all as, see, work done equal I square RT by J. Still we can write V square by J R into T. So this all have an idea, right? This we are going to apply now in numerical. So keep in mind electric energy. The commercial unit of electrical energy is kilowatt hour. 1 kilowatt hour is 3.6 into 10 power 6 joule. So this electrical energy, these various formulas remember, and as you all know, electric power work done by time, this we have P equal to V into I, that is I square R, V square by R. These are all power related formulas, remember. Now let us move to the important MCQs related to electric current and electric energy. Right? So this formula remember, Joule's law mainly. Let us move to the first sum, and here it is. Yes, good afternoon all the viewers. Amina, Vikas, Abhinav. Good evening. So just you recollect this formula. Based on that, now let us move the first problem. Today's it is electric current and electric energy based on problem. Here is the first one. See here, a rigid container with thermally insulated wall contains a coil of resistor 100 ohm carrying a current 1 ampere. The change in internal energy after 5 minutes. So keep in mind, time is given here, 5 minutes convert into second. And then resistance is given. A rigid container, thermally insulated wall contains a coil. Resistance given, coil resistance. It carrying the current 1 ampere. Then change in internal energy is nothing but the heat generated in the coil. Whenever we pass the current for 5 minutes, what is the change in internal energy of the coil? That is nothing but heat generated in the coil, correct? So, according to question, change in internal energy in the coil. Right, change in internal energy is nothing but heat generated in the coil. Right, just you understand enough. The change in internal energy is nothing but heat generated in the coil. So here time is given, resistance given, current is given. Then we know heat generated. H equal, we know that formula, I square RT based on given data. That's it. Yes, you can solve it now. Right, good afternoon, Vivin. Good. Now, you can answer me now. Yes, change in internal energy after 5 minutes. All values given. Go ahead now. Yes, current 5 into 60. Time is given. I square 1 square into R into T 5 into 60. Since minute is given, that's it. Now choose the option correctly. Yes, you will get right. This is nothing but 30 kilojoule. Right, divide by 1000. Right, kilojoule equal to 1000 joule. 1 kilojoule, 1000 joule. So 30 kilojoule is the correct option. Yes. Let us move to the next question. Right? Are you able to follow? Abhinav, Vikas, Amina, Vivin? Very simple. Direct formula you can use it. Heat produced equal I square RT. Then directly you will get. Yes. D is the correct answer. Let us move to the next question. Here it is. When a current is passed in a conductor, 5 degrees Celsius rise in temperature is observed. If the strength of the current is made thrice, the rise in temperature will be how much? So question clearly understand, when current passed through the conductor, 5-degree temperature rising. The strength of the current made thrice, 3 times. Now, according to Joule's law, we know that heat H equal I square RT. Then, for a given resistance and time, how H and I related? From Joule's law of heating, we know H equal I square RT. So, H is directly proportional to I square, right? We know that. So, I can go ahead, H1 by H2 equal I1 square by I2 square. This is equation 1. When I pass the current through conductor, 5-degree temperature rising. Now, if the strength of the current made 3 times, what is the rise in temperature? So, we know from calorimetry chapter, remember first year, the quantity of heat supplied, H equal ms delta T or mc delta T, where S or C is called specific heat. We know that, right? From the first year chapter, quantity of heat supplied equal to mc delta T or ms delta T, we know very well, right? Now, here rise in temperature and heat is directly proportional, right? So, here, since we know already H is directly proportional to I, here H is directly proportional to delta T, right? So I can write now, instead of here using this, H1 by H2 equal delta T1 by delta T2, I can write. This is equation 2. Now compare equation 1 and 2. Comparing equation 1 and 2, you will get I1 square by I2 square equal delta T1 by rise in temperature, delta T2. Right, that's it. Here you take it I1 as I, right? So, delta T1 rise in temperature is given 5 degrees Celsius, right? I2 is 3 times I1, right? Keep in mind, I2 is 3 times I is given thrice. What is the rise in temperature? Delta 2 is the question. That's all. Yes, you can do it now. Abhinav, Vivin Francis, the rise in temperature will be here. Everything is given. Now you can use it quickly. Yes, I1 is I by I2 is 3I whole square, right, equal delta T1 5 degrees Celsius by delta T2 we need to find. That's it. So here I cancel. So you will get 1 by 9 equal to 5 by delta T2. That's it. So delta T2 equal 5 nines 45 degrees Celsius. So option C is the correct answer. Yes, good Abhinav. Good. Let us move to the next one. Here it is. Calculate the heat emitted by a bulb of 100 watt in 1 minute. Direct formula. See that power is given and time is given. Right? How much heat is emitted by the bulb? 100 watt bulb, 1 minute it's working. Right? What is the heat developed? Yes, Vivian, quickly. Heat developed will be, you can answer now quickly. We know that power given, time given. We all know P equal to V into I. Right? Here heat developed equal VIT. We know that first formula, right? So here VI is nothing but power. So P into T. That's it. Direct formula. You can use it. Yes. Yes, man. It's a correct one. 1 minute is given, so 60 seconds. Do that. So power is 100 watt into time 1 minute, 1 into 60. That's it. You will get 6000 joule. So D is the correct answer. Yes, let us move to the next question. Here it is. If the coil of a heater is cut to half, what would happen to heat produced? Double, half, remain same, become 4 times. Clearly question understand. If a coil of the heater you are cutting into half, now what would happen to the heat produced? Yes, Vivin, Amina, Abhinav. Yes, you can answer it now. If the coil of the heater is cut into half, then what happens? Resistance also will become half. We know resistance directly proportional to length, right? If coil become half, if the coil is cut to half, then resistance also become half. Length become half, resistance become half. We know that heat produced, we know that formula V square by R into T. Here heat and R, how it is related? See, heat is inversely proportional to resistance. Now now R become half, inversely proportional to R become half. So R by 2. Now the 2 will come up. We know the new heat produced will be, right? Understand? 2 by R. So 1 by R is nothing but H. So the new heat developed become twice, right? So 2 times it will become doubled. So option A is the correct. Yes, Abhinav, good. Let us go to next question. This concept understand enough, you can able to do immediately. Okay, length and resistance. Length become half, resistance become half. Substitute here, heat and resistance, you will become twice. So option A is correct. Let us go to the next sum. Right? Here it is. The next one. Yes. A current of 2 ampere passing through conductor produces 80 joule of heat in 10 seconds. The resistance of the conductor is, question try to understand, resistance of the conductor, current is given 2 ampere passing through the wire, it produces 80 joule of heat, so H is also given, in 10 second time is given, resistance is the question. Yes, yes Abhinav, try now. Vivin, resistance of the conductor, we know heat produced equal I square or T. From that R find out. That's it. R equal H by I square T. All values given. Substitute. Heat developed is given. Yes, James Bond. Yes, Bikramjit. Correct. It is 2 ohm. That's it. Very good. 80 by I square is given. 2 square, it will become 4 into time. Right? 10 second. You will get 2 ohm. Is the correct answer B. Let us go to next question. Here it is. Unacademy, it is daily 2020 free practice test is going on for KCET Karnataka Common Entrance Examination. You also attempt for the test for absolute free, right? Unacademy, it will very useful this juncture. So go ahead this free practice test. Here is the next one. Three identical resistance. See that A, B, C are connected as shown in the figure. The heat produced will be maximum in B, in A, in B and C. Same for A, B, C. Yes. Now you can try now. Bikramjit. Three identical resistor. This is important. Keyword you have to see. All three identical resistor, but B and C are connected in parallel. Right? Now see heat produced, if the current flows through this, now in which resistor heat produced will be maximum? Yes, good. Option C is correct. In A, heat produced will be more. Resistance of A is greater than resistance of B and C because B and C are connected in parallel. In parallel connection, we know voltage drop across A will be greater when compared to B and C. Understand? When compared to B and C, the voltage drop will be more in A because we know heat developed equal to V square by R into T. See that H is proportional to, we know that heat proportional to V square. That's it. So heat produced in A will be greater than heat produced in B and heat produced in C, since here both are connected in parallel, right? So potential remains same, that is why. So option C is absolutely correct. Yes, let us go for the next one. Yes, here it is. A 5 degrees Celsius rise in temperature is observed in a conductor by passing a current, right? When the current is doubled, what is the rise in temperature will be approximately, right? So see that very simple problem, right? A 5-degree rise in temperature observed in a wire while passing current. While passing current, there is a 5-degree rise in temperature in the conductor. If the current you doubled, then what about the temperature will be, right? Clearly understand, if the current is doubled, then what about the temperature will be, right? Yes, Bibin, very good. Bikram, good. Yes, absolutely correct, man. Because we know that whenever we pass the current through the conductor, the heat is directly proportional to I square. We know that. That's it. So on doubling the current, when the current you double it, then what happen? It will become 4 times. Understand? Initial temperature is 5 degree. So when doubling the current, it will become 4 times. 4 into 5, 20. So option C is the correct answer. The temperature become 4 times. 4 into 5, 20 degree. Yes, absolutely correct. Let us go to the next question. Right. 60-watt bulb power is given. 60-watt bulb operates on 220 volt potential difference. The current flowing through the bulb is direct formula. What is the current flowing through the bulb? Yes, Abhinav. James Bond, quickly. Bikram. Power is given. 60-watt bulb, you are operating 220 volt. How much current flowing through the bulb? Yes, quickly. Yes, man. Bikramjit, it is 3 by 11. James Bond also correct. Power is given, voltage given, 60-watt bulb working under 220 volt supply. How much current flowing through the bulb? We know power equal to V into I. That's it. So from this, I equal P by V. So P is given 60 watt bulb 220. You will get 3 by 11 ampere. So option B is absolutely correct. Yes, Vivian, good. Let us move to the next one. Here it is. A hot electric iron box. A hot electric iron has resistance 80 ohm and is used on 200 volt source. The electric energy spent if it is used for 2 hours. If I am using that iron box for 2 hours, a hot electric iron box resistance given 80 ohm. It is used in 200 volt supply. How much electrical energy spent if I use that iron box for 2 hours? So time also given 2 hours if I used. What is the electrical energy spent? Yes. Have a try now. Vipin, Vikram, James. Yes, Amina. Basic formula. Starting I showed you electrical energy spent. Right? We use the formula. Right, Vikram? Think it over. Yes, Bikram, it's correct. We know the work done only electrical energy, right? The heat is also a form of energy, right? We know that formula. V square by R into T. That's it. So V square voltage is given 200 into 200 into T is given 2 hours. 2 hours. So 2 by resistance is given 80. So you will get 1000 watt hour. Power is watt hour. So option C is the absolutely correct answer. 1000 watt hour electrical energy spent. Yes, let us go for next problem. Here it is. Yes, two electric bulb 60 watt and 100 watt respectively are connected in series. This is the key word, connected in series. The current passing through them is more in 100 watt bulb, more in 60 watt bulb, same in both, none of this. Yes, try now Bikram quickly. Two bulb, 60 watt bulb and 100 watt bulb you are connecting in series. Then how much current passing through them? What is the current passing through them? Yes, it is correct, absolutely. That is why in physics always you need to understand the key word you need to identify. Here, the two bulb you are connecting in series, right? Two bulbs you are connecting in a series, right? So, in series connection, current remains same. We all know. For confusing you is given. Yes. Series connection, current remains same. So option C is correct. Yes, let us move to next problem. Yes, absolutely correct. Abhinav, Vivin, James, Vikram, congrats. Next one. The electric current passing through a metallic wire produces heat because of, question understand, the electric current passing through the wire produces heat. Reason, collision of conduction electron with each other, collision of atoms of metal with each other, the energy released in the ionization of the atoms of the metal, collision of conduction electron with the atoms of the metallic wire. Right? Think it over now. Right? Quickly answer it now. Theoretical question only, some of the children majorly will struggle, right? Yes, have you try now? Yes, Bikram, it is yes. Vibin, that's only, read properly the question. Vibin Francis, the electric current passing through the metallic wire produces heat because of colliding electron lose their kinetic energy as the heat. So collision of the conduction electron with the atoms of metallic wire. C, D is the correct answer. Yes, correct. Now correct. Right? Collision of conduction electron with the atoms of the metallic wire, they collide with all. That is why the collision of electron lose their kinetic energy. It will come in the form of the heat. So option D is correct. Let us move to the next question. Right? Daily 2020 practice test for Karnataka CET is going on absolute free in Unacademy. So you can enroll now. Right? Is absolutely free. Yes, the next one. Here it is. Two wire having resistance 2 ohm and 4 ohm are connected to the same voltage. The ratio of heat dissipated. How much heat is released? That's only. The ratio of heat dissipated. Two wires resistant 2 ohm and 4 ohm. See that clearly. Both are connected to the same voltage. Then tell me, what is the ratio of heat dissipated? Yes, have a try now. Vivian? Bikram? Yes, James Bond? Have a try? No. James? Check it properly. Two wire have resistance 2 ohm and 4 ohm connected to same voltage. Right? Yes, Vivian? It's a correct. Yes, Sadaf Sultana, absolutely correct. James Bond, now you got it. Because we know heat produced equal to V square by R into T. Right? So, H1 by H2, heat produced equal to here, how it is? H is inversely proportional to resistance, right? So, R2 by R1, that's it. 4 by 2, it is 2:1. Option C is the correct answer because same voltage. So H is inversely proportional to R. Yes, let us move to the next question. Here it is. A coil takes 15 minutes to boil a certain amount of water. See, I am taking certain amount of water. It takes 15 minutes to boil. Another coil takes 20 minutes for the same process. Now, time taken to boil the same amount of water when both coils are connected in series. Understand now question? Right? Clearly try to understand the question first. A coil 15 minutes is taking to boil certain amount of water, certain amount of quantity of water. Another coil takes 20 minutes to boil the same amount of water. Now, see that time taken to boil the same amount of water when both coil I am connecting and inserting now. How much time it will take? See that 5 minutes, 8.6 minutes, 30 minutes, 35 minutes. Yes, Bikram, try now. A coil takes 15 minutes to boil certain amount of water. Another coil takes 20 minutes to boil it. Now, how much time taken to boil the same quantity of water when both coils I am connecting in series? No, Bikram, check it. You didn't understand the question. James, check it. Yes, Ashik. Ashik, check it. Certain amount of water, see that it takes 15 minutes. One coil take 15 minutes to boil the water. Another coil take 20 minutes. So time taken, see the question, time taken to boil the same amount of water when both coils are connected in series. When both coils are connected in series. When both are connected in series, then yes, Bikram, you got correct. When both are connected in series, now what is the total time? When both are connected in series, T1 plus T2, because both coil will offer more resistance, right? So T1 plus T2, that's it. 15 plus 20, 35 minutes. It is option C. Right? So logically you can say, right? Yes, Sadaf, good. Right, James, check it. Bikram got correct. Yes, let us move to the next question. Option C is correct. Since time both are connected in series, it is T1 plus T2. Yes, let us go for the next question. Here it is. See that now. Two electric bulb A and B are rated 60 watt and 100 watt. They are connected in parallel to the same source. Then both draw same current. A draw more current than B. B draws more current than A. Current drawn are in the ratio of the resistances. See that question clearly first. Right? Clearly. Two bulb rating, you see the power. A is 60 watt, B is 100 watt. They are connected in parallel to the same source. Then see the option now. Now choose it. Yes, have a try now, Bikram. Bikram, no. Think it. Check it now. Two electric bulb power rating is given already. 60 watt, 100 watt. Both are connected in parallel to the same voltage. Then both draw the same current. A draw more current than B. B draw more current than A. Current drawn are in the ratio of resistance. No, James. No. Check it. Right? It's not that. Check it now quickly. We all know. See, we know that Ohm's law, man. How current and resistance are related? V equal to IR, I equal V by R. How current is related? Inversely proportional to resistance, right? Now, power P equal to VI. Now, P proportional to I, right? Now, here I proportional to V by R means P proportional to I. So, I can write power is proportional to 1 by R. That's it, right? So, here what will say in parallel, the bulb which has higher power will draw more current, that's all. So I proportional to P. Keep in mind, in parallel bulb connection, higher power will draw more current. Higher power will draw more current. So which is higher power? B bulb has more power. So option C. B draws more current than A. Option C is the correct answer. This keep in mind. I inversely proportional to R. So P inversely proportional to R. That's it. Now I and P are directly proportional. So more power, right? It is connected in parallel. So in parallel bulb of higher power will draw more current. So option C is correct. Yes, James. C is the correct one. Let us go for next one. Here it is. Right? A 5 ampere current. See that? A 5 ampere current is set up in the external circuit by 6 volt storage battery for 6 minutes. The chemical energy of the battery is reduced by 5 ampere current set up in the external circuit by 6 volt storage battery for 6 minute time. What is the chemical energy set up? Or chemical energy how much reduced in the battery? So the chemical energy, right, chemical energy reduced in the battery equal VIT. Keep in mind, voltage is given 6, current is given 5 ampere, into time is given 60 minutes. So 6 into 60, that's it, 10800 joule, that is 1.08 into 10 power 4 joule. So we know that option A is the correct answer. Chemical energy reduced, right? Amina, previous one you are asking, right? Previous one, see that two bulb power is given 60 and 100 watt. So power, see that current, more current mean I inversely proportional to R. So we know P equal VI mean P is directly proportional to I. Then in place of I can put P. Now P is inversely proportional to R. Now see which one has higher power. See, resistance low, power will be more. Resistance low mean current will be more. So power which has the highest power, it will draw more current because they connected in parallel. So keep in mind. Come to this. This is option 1 is the correct one. Yes, Amina. Got it now. Okay, now this problem, chemical energy of the battery reduced by option A is correct because current is set up in external circuit, voltage is given for 6 minutes. How much chemical energy used by the battery, reduced by the battery, VIT, directly use option A is correct. Yes, and we'll move to the last one. See that now. If 30 volt 90 watt bulb is worked on 120 volt line, the resistance of how many ohms should be connected in series with the bulb? So question, try to understand how much resistance I have to connect in the bulb. So the bulb is given 30 volt 90 watt bulb, right? So it is connected to, right, 120 volt supply here. Assume this is 120 volt supply, right? 120 volt. Now what is the current I is flowing through? Now read the question, tell me. Here it is 90 volt across resistance, 90 volt. Here it is across the bulb 30 volt. That's it. Now you understand clearly. Have a try, man. Yes, Sadaf, Bikram. Yes. See here. If a 30 volt 90 watt bulb, 30 voltage 90 watt power is worked on 120 volt supply, the resistance, how many ohms should be connected in series with the bulb? How much ohm resistance I have to connect with the bulb? That's only question. Yes, have a try now. Suppose here I take an R is the resistance that must be connected in series with the bulb. Now how much current flowing through the bulb? I. So we know power equal to V into I. So I equal P by V. What is the power here? It is given power 90 watt by what is the voltage is given 30. Right. So you will get 3 ampere. Now current flowing through the resistance will be 3 ampere. Now what is the resistance from Ohm's law? V equal to IR. Remember, from that R equal V by I. That's it. What is the voltage is given here? Across the resistance 90 volt by how much current? 3. So you will get 30 ohm resistance. Yes, Bikram, it is correct. Absolutely correct. Right? Okay, got it correctly. So anyway, thank you for all. Right? Today our stipulated time 30 minutes is exist over. We will meet you tomorrow or next day, right? With that another important concept of electric power related problem and Kirchhoff law. So until we meet the next Unacademy YouTube session, myself Vetrivel, Unacademy plus physics educator, signing off from you all. Thank you, and don't forget, use my code VetriLive. It is available in description box. Right, to subscribe Unacademy Plus course, it will be definitely helpful for your preparation of competitive examination. With that, Thank you for all the viewers. We will meet you the next YouTube session of Unacademy Plus course. Thank you all.